So this is another study by Gene Bowdish. Algebraic economic formula designed by Gene Bowdish that may possibly describe any economic formula limited by the laws of physics. Root-based economics, tax-based economics, and resistance to the formula working. How does this economic formula describe another economic formula? Example: you have an apple tree. In order to make the math simple, the apple tree will have 100 apples on it. R equals root-based economics. R equals you take something from the ground, make some sort of value out of it, and trade it with somebody else who did the same. R equals an apple tree that someone planted and it grew with 100 apples on it. T equals tax-based economics. Tax-based economics does not typically mean what many people thinks it means in the definition, because tax-based economics is a Gene Bowdish definition. When I asked lots of people what they thought it meant, it didn't mean the same thing that I intend for it to mean. However, I'm going to teach you. T equals you take one apple from the apple tree and eat it. Now there are 99 apples left. You take another one and eat it, then there's 98 apples left, and so on. T equals all 99 apples are eaten by people, then the economic formula stops working. In this example, that equals resistance to the economic formula working. Resistance equals economic resistance. In the Gene Bowdish definition, all economic formulas are limited by the laws of physics. Resistance equals when the apples are gone, the economic formula, in this case, stops working. There is a way to keep the economic formula working. Wait until next year for another 100 apples, and that may work for one person eating one apple 2 times a week, assuming all the apples are perfect enough to eat, and assuming that there is 100 apples on the tree each year, and the apple tree has enough water and sunlight, and it is warm enough, and there is no bugs, worms, etc. eating the apples. And you think of another problem where there might be, or it might slow the apple tree from growing or not grow at all. Kind of shows you the economic resistance to the economic formula working. I think you get the idea. Let's see, 52 weeks in a year. 52 times, see, I guess there's not enough apples. A little bit short. Or, please take the seeds as you eat the apples. Sorry. Please take the seeds. Sorry. Plant the seeds as you eat the apples. Then 100 apple trees producing 100 apples equals 100 trees times 100 apples each equals 10,000 apples total. And if you plant 10,000 apple seeds while you eat the other apples, then there are 10,000 apple trees producing apples, which is 10,000 apple trees. 100 apples each tree equals 1 million apples. Way more than one family needs. So now the family can start selling the apples for money, trade for other things, etc. And then the family can get the things they need from the other families who are doing something similar with different things, like orange trees, grape bushes. I think you get the idea. Of course, the laws of physics come into a challenge again. Do you have enough land to grow the trees? Do you know how to grow the apple trees? Or can you find someone who knows how to and wants to help you grow that many trees? Are you starting to understand the algebraic economic resistance? And how much do you understand, or can you find someone to help you understand? I hope you liked this study I did. Please subscribe, so you'll know when I do another video. Please share so other people can learn. Like it if you like it. Example. Another study by Gene Bowdish.